Hello and welcome to the second day of BalCCon 2023. Jaromir will present to you abusing Electron-based applications in targeted attacks. Enjoy.
Okay, thank you. So my talk will be about Electron-based applications being abused in targeted attacks. So this will be the outline of my presentation. So after the introduction, I will talk a little bit about Electron framework, what it is, if you are a developer, like how very quickly, how you would maybe develop like some simple application which will work on different platforms. Then I will mention few methods of abusing these Electron-based applications which we have seen in the wild. And then I will finalize my presentation with 3 cases which we have seen in the wild and when threat actors abuse like few applications and use them to distribute additional malware. So, introduction to the Electron.js framework, if you haven't seen it before, or if you haven't heard about it before. It's an open source project when the developer uses the web developing languages like JavaScript, CSS, or HTML. So he has one code base, so he writes the code, and then the developer can compile or build it to the one source code to all the 3 different platforms, to macOS, Linux, and Windows. The Electron framework uses or is based on Chromium and Node.js, so it incorporates both of these projects into its binary. So Node.js is just like server-side or backend, like JavaScript runtime environment. It runs the JavaScript engine. It's like asynchronous, event-driven. It uses lots of packages by using something called Node Package Manager. The Electron applications borrow from Chromium the architecture, the multi-process architecture. So it means that there are like several different processes. There is like one main single process which is responsible for application entry point, which runs the Node.js environment, which creates and manages the applications, the windows of the browser windows. It controls application lifecycle, so when the application is started, when the window is open, when it is closed, and so on. It can interact with operating system via custom API. Then there are like a few more rendering processes, and each renderer process is for each own like browser window, and it's responsible for rendering web content. There are also like some GPU process, sandbox utility processes, and so on. So when you see the process in Process Explorer, you can see like for one application, in this case you have like 3 different processes, and you can see here as a parameter the type of the process for which feature it is used. Electron is very popular, so on their website, if you go to this website, you can see that they boast that more than 500 different applications are built with Electron, and some very known applications like GitHub Desktop, Discord, Skype, WhatsApp, Teams, Slack, Visual Studio Code, and hundreds of others. So if you are a developer, or if there's a developer, what it means like developing the simple Hello World application in Electron framework. So usually you have a file called package.json, which is the manifest, which contains some basic information about the application, like the name, version, author, some dependencies. Then you have index.html, which is the template of the website, in this case very simple hello world. Then there is like main JavaScript file, which here in the beginning you can see that it creates a window. Take the pointer. Yeah. So here you can see it creates the window. Then it reacts to some events, like when the window is ready, when application is activated, when windows are closed, and so on. And there's like one more thing called preload.js. So basically for some security reasons, the renderer process shouldn't have, or it's better if it doesn't have access to the Node.js API, it doesn't have access to, like it's like more restricted, but the preload.js script is run with like more privileges. So this is the very simple example of the file. So then if you are a developer and you wanna distribute this project to your users or to customers, you need to package it. For packaging, you can package it either manually or you can use tools like Electron Forge or Electron Builder. In this example, using Electron Builder is very similar. You call the command npx, which means node package execute. Electron-builder is the name of the package, dash, M for macOS, W for Windows, L for Linux. Then you run it, it runs for some time, and in this demonstration, or in this case, for platform Darwin, for platform macOS, it creates zip file or a DMG file. For Linux, it creates here snap and app image file. For Windows, it creates ANSYS installer. And we can run this one application in macOS, in Linux, in Windows, and basically it looks almost the same. If you are a reverse engineer and look into this compiled application and you maybe unpack the archives, inside of the archive you can find like one kind of interesting file which has extension .asar, so it's like ASAR archive. It stands for Atom Shell Archive Format. It's like the simple format which contains all the sources concatenated like one file after another file. So in the beginning of the file, so here you can see some 16-byte very simple header with some length of the file, and then it follows something which looks like JSON object. This JSON object lists all the files, and every time there is the file name, size of the file, and offset in which the file starts. So all the files are like put into one archive. This ASAR archive is usually found in resources directory in all these formats, zip, DMG, snap, exe, everything is in the same resource directory. You can easily extract it if you have like Electron framework installed, npx ASAR extract or extract file. There are also like 7-zip plugins where these ASAR files behave like normal archives, or you can even write your own tools. It's like very simple to handle these files. So this is for the introduction of Electron framework. Then like few cases about how this framework or how these Electron-based applications can be abused by the attackers. So one thing is of course exploiting vulnerabilities. There have been like very interesting presentation or paper in Black Hat USA 2022, which was called Electrovolt Pawning Popular Desktop Apps While Uncovering New Attack Surface on Electron. And in this presentation, they will talk basically about like 3 kind of like security features which can be enabled, which is good, or disabled, which is bad for the security. And these are here. Node integration, which is the ability of the process to access the full Node.js capabilities, which can be either enabled or disabled. And the access of these capabilities is from renderer process, which should have like limited, scope of abilities. Then there is the context isolation. So in the beginning, I said there is some preload.js script which should have like more privileges, and later the loaded website should be like limited privileges. But again, this feature can be enabled or disabled. And the third case is sandboxing. Again, sandboxing can be enabled or disabled. And in this paper, they describe like different applications, different vulnerabilities. For this presentation now, the most important or the only important thing is this line, this CVE 2021-21220, which we have seen in the wild. And I'll also mention that this vulnerability is it affects Chromium prior to this version, 64-bit version for Chromium, and it works only for non-sandboxed windows. So if the application has, or if the Electron application uses the older version of Chromium, and for whatever reason the developer disables the sandbox, which I will talk about later in one of the cases in the end, then this application becomes vulnerable. Of course, this vulnerability is like easily available on GitHub, for example. So if threat actor or any researcher wants to see how it is, you can just search for it, get the source code, find this shellcode variable, modify it, and use it for yourself. So one thing is exploiting the vulnerabilities, and other case is just the patching the existing application, and it can be achieved, for example, by the threat actor having access to the development backend. So, for example, it's the kind of like supply chain attack that the threat actor gets access to the backend somehow, then modifies the application, and the application then gets distributed to the users or to the victims. And for the modifying the applications, we have seen some scripts or some tools either replacing completely this UpAssar archive with the patched version, like in this case, that the script checks the size or length of the file. If it doesn't match like one of these predefined files, it sets this temporary variable, which later activates downloading file from this suspicious URL address and replaces the UpAssar archive in the resources directory. Or you have this patching script in PowerShell, and it searches for these strings and replaces them with some other strings. So here you can see that, for example, auto updater in the beginning in the application is disabled. Then here there is some URL address which gets replaced and changed to something kind of suspicious. And now I'll talk a little bit about 3 APT cases which I helped to investigate like in the past year or half a year. These cases or these threat actors, like the first is like Iron Tiger threat actor, an application called MimiChat, then another actor which we didn't give him any special name, but they abuse the applications called Com and LiveHelp customer engagement platforms, and the threat actor is called WaterLabu, and the application is called Meitia. So for the MimiChat secure chat application, the name Mimi comes from Chinese language, where the Mimi means secret. So it's like some kind of like secret chat application, and their website at the time of when we did the research looks like this. So on the left side, you can see that they offer like 2 versions. This is for macOS version and Windows version, and both of these versions have been Trojanized for some time in the past. And on the right, there are like mobile versions, Android and iPhone or iOS version, and we haven't found anything malicious in the mobile versions, because the desktop versions, the macOS and Windows, were written in Electron framework. So when we extract this UpAssar archive of the desktop versions, we can check like the JavaScript files, and in one file which is called electron-main.js, which is here in the archive, it's like one of many JavaScript files, we can notice like this kind of suspicious marker. It starts with eval function packed, and it kind of resembles the marker of Dear Edwards JavaScript packer, which is the tool, which is online tool, so you can go online, search for their compressor, paste some simple code there, click pack here, this is the result, and the threat actor or the user can embed it into the JavaScript code. After deobfuscating the code, we got something like this. The tool or the deobfuscated code checks the platform, in this case Windows 32. Then there is hard-coded IP address, from which it downloads like 3 files, 1 executable, 1 DLL, 1 binary file, and then executes the executable. So in this case, it downloaded malware which is called Hyperbro. It's like the malware which is attributed to the Iron Tiger threat actor. For macOS version, it looks very similar. Checks the platform to Darwin, hard-coded IP address, file downloaded is named rshell. After downloading, chmod +x, so it's made executable and then executed. Interesting thing is that like one day when we did the analysis, one day in the morning we downloaded the file and the file was clean. This is the picture on the left. A few hours later, we download the same file from the same URL because it was like the new version, and suddenly we noticed like one change, like all files have the same time or almost the same time, but electron-main.js has different time and different size. So we think, or it looks like the threat actor had access to their backend. They were monitoring when the developer developed or released the new version, and then when the new version was released, then they quickly patched it. It's important to notice that this MimiChat, like when you run it on your computer, it usually displays some warnings. So in Windows, there is one warning that digital signature was not verified. The victim click run, ignore it, and gets infected. On macOS, there have been few more warnings. The first warning was by Safari browser. The victim clicks allow. Then it mentions that it cannot be opened because developer cannot be verified. So the victim needs to go to the system preferences and security and privacy tab. Then choose the option open anyway. Then this open button appears. Click open and get infected. When looking into our telemetry, we have found like one interesting script. So we had the malicious domain, and we found like this GET request to file called script.js, and also we found post script.php to the malicious domain. And at the time, the script was alive, so we downloaded it, and we found out that this script was JavaScript password grabber. This subdomain.domain was some authentication portal for development tool to which the developer connects. Inside this authentication portal, the script, the password grabber, was injected, and when the developer enters the credentials get infected to this malicious domain, and this is probably the thing how attackers got access to the back end of this application, and they could modify it. Now I will continue with the second case. These are the Com and LiveHelp customer engagement platforms. So basically, it was like at the end of the last year, there have been like few written blog posts by different researchers, by us, also by researchers from other companies. So basically, the blog posts were released in maybe September, October. But when checking our telemetry, we have found in like some suspicious traces, maybe till February 2022. So it seems like the threat actor has been like kind of active for maybe half a year until something wrong was discovered and published. So few more words, like what are these customer engagement platforms? So basically, if you are the person who needs to communicate with the customers, so you install this application, this agent console, and this is the Electron application. You run it on your computer. Then you have the few websites, and into the website you inject or insert this kind of widget. And when the customer or visitor wants to talk to you, he clicks on this widget, registers, and opens this kind of communication window. So the customer writes in this window, and you answer to his question through this agent console. So this is what these programs are about. This is what these programs are about. So the program was Trojanized, and the attack like flow looked like this. So there's the Trojanized Electron application, which loads the JavaScript backdoor, which then drops legitimate signed executable file. This file has sideloading vulnerability, so it loads DLL file, which is decryptor. The decryptor loads and decrypts the binary file, loads the first stage of the malware, which then downloads and loads the second stage of the malware, which then downloads and runs some of these plugins. The plugins can be information stealers, Skype, Telegram stealers, screenshot takers, SOX proxy. It can be package, it can be zip package with new update and new version of the malware. Again, if you are a reverse engineer, you go to the resources directory, AppAsar archive, find or check the JavaScript files. One of them is called main.js. You look at the end of the file, and there is some kind of like one paragraph which contains long hexadecimal string. So when you beautify it, you can see long string, some decryption, this is the string, some decryption, some XOR before, and then eval, basically like execution of some JavaScript code. The decoding is quite simple. You can use this CyberChef tool, put there the key, and this is the CNC URL. So when you get the content of the CNC URL, you can notice some backdoor functions. So one function is collection of operating system information. So it collects like the environment fingerprint, lists of running tasks, computer name, username. Another function can be shell manager, which uses here cmd.exe like command line to run command line commands. And then there are also like additional stages of the malware, either responsible for trojanizing or modifying original application if necessary, and dropping the additional malicious file. So inside of the JavaScript source code, you can also notice a variable like these, which contain hexadecimal strings starting with 4D5A90, which is like MZ marker, which is like executable file, and some binary file. Then this content is dropped into these three files, executable, DLL, and some binary file, and executed. Third case I will shortly mention is this Meichia live chat application. So this application is basically kind of similar like in the previous case, but again on the website owner or operator includes this kind of widget, this kind of small button. Visitor clicks on the button, communication chat window opens, and he can talk to the website owner. This was quite interesting how we discovered this case, because at the time we have been analyzing some campaign which was related to or responsible to some stealing cryptocurrencies. And in this campaign, this Cobalt Strike sample connected to one online repository, and from there downloaded like some files and used them for the persistence on the infected machine. And the online repository at the time was like open directory, so we were able to download quite a few scripts and files and analyze them. And one of these files looked like this. It was the exploit for this CVE 2021-21220 vulnerability, as I mentioned in the previous sections. Here in the title, you can see these Chinese characters, which says the Meichia application. Later, you can see the check of user agent, if it runs within like the Electron environment, and so on. Here, this exploit web page, it downloads some picture, which I will show on the next screen. So it will display some picture, and on the front end and on the back end, it runs the exploit code. Also notice here that the name of the application is MeiQIA, but the attacker uses typo squatting domain MeiQLA. So L and I looks quite similar, but this domain is controlled by the attacker. So when this page or when this file is displayed or executed within the Electron application, something like this displays like to the victim. This is some kind of like payment confirmation of the cryptocurrency. But this is like only the visual display of the picture, but on the back end, the malicious JavaScript is executed. This Meichia application, in some old versions, they opened the external links or external content within the application by calling load URL. So the content of the application is opened inside of this application, which is written in like older Electron framework. And in older Electron framework, the sandboxing was disabled. And also in these applications, sandboxing was disabled. So as I mentioned, this CVE vulnerability worked only for cases when sandboxing was disabled, and this was exactly the case. Yeah. And here, in the newer versions, the developers of this Meichia application noticed probably this vulnerability, and they inserted in the source code this command, which after translation means, for security reasons, all links are opened through external browser. So it means in the newer version, if they see the link to some other website or to some other content, and if the user of this application clicks on the content, it opens in external browsers. So it opens either in Firefox or Chromium, not within the Meichia, not within this Electron application. So basically this is like more safe, because modern browsers should by default use sandboxing, and it makes the exploit not working in these cases. So let's show like quickly the schematics of the attack. So you have this targeted Electron application which is running somewhere. The threat actor sends the malicious link to them. Then the user using the Electron application clicks on the link. The link connects to the code repository, downloads code with exploit. Exploit gets executed. The exploit runs the Cobalt Strike. Cobalt Strike runs some additional batch commands which patch this Electron application, which later delivers additional JavaScript payloads. So what are these scripts? As I showed before, these scripts patching the application either replace the APASAR archive or replace like some smaller parts of the code. In this case, there was a file called create-window.js inside APASAR archive. And in this file, we have noticed like few interesting modification. One of them was this strange URL address. So suspicious URL address is one thing. Then on handling event of creating new window, so on new dash window, here it runs or here executes this JavaScript code. And inside of this JavaScript code, you can see like links to many different suspicious domains which feed or which provide additional JavaScript codes or additional payloads. One script which is quite interesting is the script for grabbing credentials and stealing cookies. So in this script, here you can see it checks the title of the window. After translation, this says denglu, which in Chinese means login. So if the script is running within the login window, then here it gets two elements. One element called email and another element called password. It gets their value, and here this value gets exfiltrated to this attacker-controlled domain. And similarly for cookies, document.cookie exfiltrated here. Now I'm coming to the conclusion. So very quickly, like takeaways, like Electron applications are usually like big projects. So when you download the archive, it has sometimes it has few hundred megabytes. You extract all the files. There are like few hundred files. You find APASAR archive. You extract it. You have another hundreds of files. So sometimes it's like when you see it maybe for the first time and try to reverse engineer it, you don't know where to start because there are like hundreds of files. In these cases, we noticed that threat actor abused some of these applications to deliver additional malwares. So in this case, I would say that the threat actors, or all three of them, have quite strong technical capabilities. They patch the Electron applications, and these Electron applications usually serve as downloaders or droppers of additional malware. Because the JavaScript is quite powerful, but having native malware is even more powerful and has more capabilities. The threat actors have the custom toolkits running on different platforms, usually Windows, Mac OS. And the motivation of the first actors was like the espionage, stealing files, getting some more information about the targets. And the third threat actor, we think this motivation is mainly financial. And this is like the last slide. Like this overview is like very quick, very brief. But about each actor, we have written like different blog posts. So if you are interested in these topics, you can just take a picture and have a look at these blog posts. There are like many more details which I couldn't cover in this presentation. So I think it's all. So I don't know if you have any time for questions, either now or you can see me here today or tomorrow, so you can ask me anytime about anything. So thank you for your attention.
Thank you so much. We have time for maybe 2 questions if anyone has any questions. Yes, we do have questions.
I have a question regarding when you identify command control server, what actions you take against the command control server, and did you take or you're continuing researching, observing that command control server and gathering more data to understand the attack, or you are taking action because, for example, Amazon Web Services, maybe you send report to Amazon that host is command control server, so they shut down it, or maybe you flood it with fake data to prevent that getting other requests from infected clients or anything, or?
So, usually, like I work like for security companies, so usually when we find some malware, it can be either the sample or URL address, we just add the detections. So the users who are using our product are protected because the access to this CNC server is blocked, or if the malware is executed on some other client and it uses our solution, then it gets blocked. That's the main thing what we do. Like no other action. Well, yes, but I mean we like track like many things. So sometimes you maybe report to, let's say, to the developers that they are probably compromised, and sometimes you get answers, sometimes you don't. So it's like difficult.
Okay, we are in companies where I was working. Okay, when we get some information about command control servers, okay, we block it on network level so our employees are protected.
Yes.
But yeah, the point is that there is a clients that not using your software, not getting signature updates for that, and they are still vulnerable, and threat actors continue to doing their business because nobody preventing them of doing their operations, because yeah, you will protect the part of users, but the rest that you also could protect on some way by some additional actions will stay vulnerable, and it will be.
I mean, it depends where the CNC server is hosted. It can be hosted on some bulletproof hosting.
Yeah,
even if you ask them,
okay,
they will not take it down. So you cannot protect anyone. So we try to do our best, but not everyone is protected like all the time.
Okay, thank you.
Any more questions? Nope, that seems to be all. Then, thank you so much
Okay,
for the
thank you.
presentation.